Gain structure is one of the most important topics in audio, but I just don't think it gets the attention it deserves. A solid understanding of gain staging is absolutely essential, from mixing music to optimizing the performance of a sound system. But if you're new to this channel, my name is Kyle. Welcome to Audio University. First of all, gain refers to the level difference between the input and output of a system. Proper gain structure means that the level of the signal is optimized throughout the entire signal chain. If the level of the signal isn't optimized at any particular stage of the signal chain, then the signal quality will be degraded. As audio technology has changed over the years, the way we approach gain structure has also changed. However, the goals have remained pretty much the same: to minimize noise and distortion while maximizing dynamic range and headroom. Let's take a look at how gain structure can help us to achieve these goals. I'm sure you've heard the effect of turning a sound system up beyond its limitations. As the signal starts to exceed the limitations of the circuitry, the signal begins to be distorted. Now, don't get me wrong, this isn't always a bad thing. Muddy Waters and other guitarists of his time, they revolutionized the course of music with innovative guitar sounds that harnessed what some would call improper gain staging. However, while some types of distortion are pleasing, different types of systems distort audio signals in different ways. The consequences of overdriving an analog circuit or saturating analog tape are usually much more forgiving than the consequences of clipping a digital audio system. It isn't just the individual channels that you need to worry about either. You may have encountered a situation where none of the individual channels were clipping, but the meters on the master bus were solid red. It's best to leave some headroom in your mixing system so that the combined level of all of the inputs doesn't exceed the limitations of the master bus. Later on, I'll show you how to set up a mix to make sure that you get this right. But for right now, it's just important that you understand that you need to leave enough headroom when setting levels as to avoid overdrive and distortion. We also want to set up the gain of the system to minimize noise. The signal-to-noise ratio is the difference between the noise floor and the signal. Generally speaking, the quieter the noise floor can be in comparison to the signal, the better. Let's say you want to record the sound of your voice to a tape machine. Using the gain knob on your microphone preamp, you're able to control the level of the signal to be recorded. Turn the knob up and you'll get a louder recording. Turn the knob down, you'll get a quieter recording. To avoid overdriving the tape machine, you're careful not to turn the signal up too loud, but you should also consider what might happen if the signal is too quiet. The tape has a certain level of inherent noise of its own. The tape noise stays the same no matter how high or low you set the mic preamp. If you record a very weak signal to the tape, the signal-to-noise ratio will be very small. Plus, once your voice is recorded, you'll need to turn up the signal to bring it to a usable level. And when you boost the signal, you'll also be boosting the noise. If a strong signal is sent to the tape from the beginning, the signal-to-noise ratio will be much greater. And it's not just analog tape that has inherent noise. All devices will add some bit of noise to the signals passing through them. Each time you add a device to the signal chain, the signal will acquire a bit more noise. It might not seem like a substantial problem until you hear the combined noise floor of all of those devices stacked together. As the noise floor rises, the quietest signals will begin to be indistinguishable from the noise floor. This brings us to another big difference between analog and digital equipment. Well, you've got to be very careful not to record too weak a signal to analog tape or through an analog device. The noise floor of digital systems is much, much lower and therefore much more forgiving. When setting levels, you'll be searching for the sweet spot between too high, which might lead to overdrive or distortion, and too low, which might end up shrinking your signal-to-noise ratio. And like I said before, the approach is a bit different depending on if you're using analog or digital gear. With analog equipment, we tend to set levels a bit higher because noise is our biggest concern. Plus, if you slightly exceed the limitations of the equipment, it may even sound desirable. With digital systems, we tend to set the levels a bit lower because noise is a much, much smaller problem, and the consequences of overdriving a digital system into clipping will completely ruin your recording. You'll even see a difference between the types of meters used in analog versus digital systems. When setting levels in the analog realm, we'll usually aim for peaks around 0 dB VU on a VU meter, which is equal to plus 4 dBu. Plus 4 dBu is the professional standard for line level signals. Most digital systems use an entirely different scale for metering called full scale. When setting levels in a digital system with a full scale meter, the signal should never exceed 0 dB full scale or 0 dB FS. If a signal reaches 0 dB FS, it won't be properly quantized by the system, and you'll start to hear the sound of digital clipping. Opinions vary on this, but I like to set signals so that the peaks are at about minus 12 dB full scale, and the signal averages out about minus 18 dB full scale. This gives you a lot of headroom for the signal to breathe, while also paying attention to maximizing the signal-to-noise ratio. Throughout the signal chain, there are many places other than the microphone preamp that you can adjust the gain. So it's important to be aware of each stage of gain so that you can optimize the level of the signal throughout the entire signal chain. The first place that you can control the level of a signal is with the output volume adjustment of the audio source. So I like to start with smartphones, laptops, DJ turntables, outputting at about 80%. Outputting a healthy level like this means I won't have to increase the gain of the signal as much down the line. The second stage is usually the input preamp. Like I mentioned before, I like to set the preamp so that the input meter shows peaks at about minus 12 dB full scale in a digital system or 0 dB VU in an analog system. In your DAW software, you can sometimes adjust the gain of a region. This is a good place to set initial levels for your mix if you're mixing tracks that were sent to you at a level that is too high or too low. When using an equalizer, you're adjusting the gain of the signal. Boosting high frequencies with a high shelf will increase the overall level of the signal. Cutting low frequencies with a high-pass filter will decrease the overall level. You should also consider the effects of dynamics processing, like compressors, expanders, and duckers. These tools often have a makeup gain knob that allows you to increase the level to compensate for the gain reduction you've applied. Each auxiliary send knob, channel fader, bus master, and master fader is a place where you can influence the gain structure of the signal chain. In general, it's best to start with faders at unity so that signals pass through without being boosted or attenuated. Rather than using the master fader as your system output volume, it's best to keep the master fader at unity and adjust the loudness of the system with the monitor knob on your audio interface or the amplifier level control to find the appropriate level within the room. Let me show you the process I would use to make sure I'm setting up proper gain structure in a new session within a DAW. These steps might seem really simple, but trust me, this is probably where 90% of mixes go wrong. I want to set the initial level of the tracks so that they're at a workable level that still leaves some headroom in the master bus. In some DAWs, you can adjust the region gain directly, but if your DAW doesn't have this feature, you can simply drop a trim or gain plugin on each channel. I'm going to set the level of each track so that the meter on each input is at about minus 12 dB full scale. Notice that there's still plenty of headroom in the master bus with all of the track faders at unity. Taking the time to set up each mix like this will allow you to work more comfortably within the limitations of your mixing environment. So let me know in the comments, what is your process for setting up gain structure in a new mix? To learn how to make your next mix even better, watch the video that's on your screen now. I'll see you there.